Good evening and welcome to Tinkering with Edkelar. Now, what a coincidence! I had to shuffle things around in my queue for a bit, and what came up on top was the next combo video, Breadboards Part 2. As I mentioned, these can be quite a rabbit hole for collectors of odd but useful things for sure. In this video, I have another set of 3. If you haven't seen it yet, be sure to check out the first breadboard video. I'll refer back to that if relevant. This batch has 2 more items made by E&L again, as well as one made by Knight Electronics. So, let's dig in! First off, we have a small solution. This one is called Pencilbox LD-2. It comes in a plastic case for protection. The shipping process had some issues, but eventually it arrived. Disassembly is simple. There are 4 screws in the corners that hold down the PCB against spacers. The spacers are in turn held in place with screws from the outside, which also hold the rubber feet. Speaking of rubber feet, these have deteriorated considerably and are more like hard plastic now. Yuck! I don't really like the 45-degree LED holders. I think they mean well, but somehow they make it look cheap to me. So I just resolder the LEDs without them in a normal row. New rubber feet. A rather close match too. Now this model doesn't come with a built-in power supply. To provide power, it relies on a 5-pin DIN socket. Clearly, at one time there was a power supply to go with it. It should provide 5 volts as well as plus-minus 12 volts. For testing, I can use my lab power supply. The second LED display was missing a segment, but I found a pair of fitting replacements in my stash. adding the usual magnetic strips to tie in with my other models. There was a small reference sheet in the lid. I recreated it in Inkscape and replaced the torn up version with my own, including the power connector pin out, just in case. Since I don't have a matching power supply, I set out to make my own. The cheapest option that doesn't require a donor device was to use a triple output module and wire it up in a project box. I use an equal 5-pin DIN socket on that, so I can connect the Pencilbox with a straight-through DIN cable. And as a bonus, I thought it might be useful to have the voltages available via some binding posts too. Adding a bit of labeling. And done. And now, works. Let's go over the feature set. Supply voltages are +5, +12 and -12 volts. The digital supply, VCC, can be jumpered to either 5 volts or +12 volts. There are 2 BNC adapters, 8 logic switches, 2 momentary switches for logic level outputs, a clock generator for 1 Hz, 1 kHz or 100 kHz, 8 digital LEDs and 2 7-segment decimal decoded displays. All signals are available on the central connector strip and are labeled on the silk screen. Up next, we have the E&L CADET II. I found a flyer for that, and it turns out that CADET stands for Combined Analog Digital Electronics Trainer. There have been 3 models around, with some revisions even. The one that I have here is the middle of the range. The top model would be the CADET Master Lab, which came with an integrated digital voltmeter and a breakout DB25 connector. This one is not only quite large, 4 full-sized breadboards next to each other, it is also quite heavy, with a sheet metal case. My unit was missing the actual breadboards, but no worries. I wanted to convert it to my magnet strip solution anyhow. And the case contains 2 transformers and a power supply board. Fun fact, That PCB is held in place just by the heatsink mount for the pass transistors. No other mounting points. Quite bouncy. Interesting. The large transformer is actually a dual voltage one that got hardwired for 120 volts. Bummer though that the smaller one isn't. But since it's a rather simple one, I look for a replacement rather than rewinding. Digging into it reveals that the top cover is actually a PCB with black solder mask. Right under that cover PCB, there's another one that carries the internal circuitry. I removed the connection blocks from the top PCB so I could give it a good scrub. The metal case was a bit banged up. Not much, but I still opted to repaint it. And while I'm at it, I also cut out the wire outlet to install a proper socket. Devices store much easier without dangling wires. I checked the inner PCB for visual signs of problems, and oh boy, did I spy one! That poor resistor R72 couldn't resist. Going by the visual indication, I guess it has failed before, which caused the burn mark on the PCB, and also has been replaced already. But the current one is also in a bare metal state now, so something has caused it to melt too. Now I couldn't find any schematics for this thing, so I had to reverse engineer it. It would seem that the resistor is in series of the regulated supply rail that drives the signal generator and probably other things on this board. I found the same circuitry mirrored on the other leg of the supply, so I assumed the same resistor value, 10 ohms, and hooked it up for a test. Nope, that's not an even plus-minus supply at all. So the resistor might have been acting as a fuse, and the real fault is elsewhere. After writing down some voltage levels to check against the circuit, I found that one of the transistors has stopped being a transistor. I had a suitable replacement around, so one more try. Yes, it works! And just as a precaution, I replaced both of the 10 ohm resistors with half-watt ones to, hopefully, keep them from bursting into flames when limiting current. Mounting stuff again. The two PCBs have spacers. The top one screws into those through the white connection blocks, but not all of them. It is quite a puzzle to make sure that the screws line up properly. At first, I mounted the potentiometers just as they were. This unit doesn't seem to be old enough to warrant a disassembled clean. But checking up on them revealed that one of them did not do anything at all. It had the nominal value across the outer pins, yes, but it seemed to be open on the slider. Wiggling the knob a bit showed some resistance, so I thought, great, a contact issue. And here's one potentiometer design I despise. It has the axle riveted to the slider assembly. No way to take it apart and assemble it again. That's why I wasted quite some time trying to get the wiper to make better contact between those two plates. Only to eventually realize that center ring contact isn't there anymore. It was just the carbonized remains of one. Somebody clearly blew up that potentiometer. I also had almost identical binding posts around, so I could replace the factory ones. One of those was bent, and I prefer all equal to one is almost the same. The little jumper wires between the PCBs are socketed on one side and soldered SMD style on the other. Despite being made from flexible wires, almost all of them snapped off. Resoldering time. Recapping the power supply. And adding new thermal paste. New rubber feet. New labels, and mounting things inside the case again. The main transformer will be rewired for 240 volts, and I found a cute little toroidal transformer to replace the smaller one. I just needed to make a little mounting bracket for it. This is what powers the AC output. Center tapped is easy enough, since it has two equal secondaries. The replacement potentiometer is spot on, but the knob has a D-mount, which wasn't an option for the new one, so I had to mill a bit off. and contact. Nothing? Oh, oops. It works better when you plug it in. Testing the core functions. On this model, the logic level LEDs are tri-state ones. They react to clear high or clear low level inputs by either red or green indication and are off when there isn't an appropriate input at all. Nice! The switches next to them are to select TTL or CMOS levels as well as 5 volts or the V+ voltage as reference. Now here's an interesting addition, a logic probe section. It lacks the VCC or 5V selection. Instead of that, you are supposed to provide the appropriate voltage via the VCC input. Strange. Anyhow, the input section is mapped to the high-low LEDs just like the other LEDs. What makes it special is the orange LED. It will stretch a pulse to a visible duration in pulse mode or latch on in memory mode, kind of like the memory LED on the HP logic probe. Other than that, we have a function generator to provide the usual triangle, square and sinusoidal waveforms at a range from 0.1 Hz to 100 kHz. Should be enough for breadboarding. It also puts out the same frequency as a TTL clock. 2 open collector push buttons, 8 logic switches, a BNC connector, a 1 and a 10K potentiometer, 2 toggle switches, an 8 ohm speaker and 2 digital decimal decoded displays round off the features. And now on to this model, a Knight Electronics ML2010. It comes inside a sturdy metal tool case and is by far not only the most recently acquired one, but I think also the newest one I have around. It also features a perf board for prototyping attached to one side. Seems that just about everything is mounted to the panel. Only the transformer, power socket, speaker and the fan are mounted in the base of the case. But at least everything is plugged in. Other than the usual cleaning, this one has a 120 volts only transformer, which makes it very inconvenient. I'll have to change that. Removing all the PCBs to give the panel a good clean. That is crooked. There is nothing to support the panel on the long side, and the bent over edge clearly wasn't enough. After a good scrub in the basin, I bent the panel back into shape. Putting all the PCBs on the panel again. These all use surface mount components. No recapping this time. Now to the transformer. It comes apart pretty easily. The core isn't quite as tightly stuffed as the others I had around. Once the lacquer gives in, all the sheets are just a breeze to take out. In other good news, this one has the primary coil next to the secondaries, not underneath them. Yes! I can leave all the secondaries alone. Did you notice that I finally got annoyed enough to mount my winding machine to a base plate? The original had 258 windings, which means I should put on 516 windings with about half the cross section. Now I don't have exactly half that, so I have to double up some slightly thinner wire. I also keep the thermal fuse on the inside, just in case. After soldering on the wires again and testing the resistance, the core goes back in. Only one sheet short of the original packing this time. Usually it's 2 or 3. I really think this one was not as tight as they usually come. And before wrapping it up, I give it a quick test. The connections are a bit close together. Yikes! These connectors were too close together indeed. At least I now know that the fuse in my isolation transformer works. The power supply does have a few electrolytics, but with the age of this unit, I'd say they are good to go. And now a quick function check. The indicator LEDs and switches are first again. The power supply is next. We have ±12 and ±5 volts as fixed outputs, as well as an adjustable ±0 to 18 volts and a 15 volt center tapped AC output. For generic functions, we have 2 toggle switches, 2 momentary switches next to 2 TTL toggles, a 1K and a 100K potentiometer, and an 8 ohm speaker. Connectivity is provided with 3 BNC connections and 2 sets of DB9 and DB25 panels, one for male, one for female connectors. Those both provide a 25-pin female connector to tap into them for breadboard wiring. The function generator is similar to the one in the Cadet, but it goes from 1 Hz to 1 MHz. Triangle, square, and sinusoidal waveforms are the options here too. It also features a clock output for a TTL signal of the same frequency. Now where this one adds to the feature set are the inputs: burst, AM, and sweep. These are voltage control inputs. If the burst is pulled to ground, it disables the output. That way you can create signal bursts based on other inputs. The AM input is to control the amplitude based on the input voltage here, and the sweep one is altering the frequency. The sweep generator creates a ramp signal, which is useful for driving the inputs of the signal generator. The pulse generator creates pulses based on a repeat rate and a duration setting. The overlap LED will light up when the settings are not compatible and result in a DC output. I spent some time in KiCad and created a PCB layout for the perf board, so I should be able to get a few of those ordered eventually. And as a quick side note, I found some reasonably close replacements for the broken connector in the CD1 model from the first breadboard video. It seems that single IC socket pins work. They just don't have the knurled part that would hold them into the plastic, but I think the soldered on wire on the other end will do the job for that. At least now I can use the first switch here too. And while I'm at it, I stocked up on breadboards for my magnetic system. And that's it! Another batch of breadboard platforms ready! And yes, there will be another episode coming up, as I already have 3 more models, but only one of them is done. I hope you enjoyed this episode. See you next time! And adding fresh termite. Yeah, of course, thermite. Yes, thermite paste. Yes, that would help. And adding fresh and adding fresh darn it. And adding fresh darn it. And adding new thermal paste.